Good morning, class. So we'll be looking at quadratic equation. But firstly, we'll first of all introduce ourselves to quadratic expression. A quadratic expression is an expression in which the highest power of the unknown is 2. The highest power cannot exceed 2. In our previous class, we've already discovered what we mean by linear equation. If it is meant to be a linear expression or linear equation, the highest power is going to be 1. Like for example, you have 4x plus 3. This is linear. Unlike this, that we have x squared plus 4x plus 3. And that is quadratic in nature. However, the highest power of unknown sometimes can be more than 2. It can be 3, it can be 4, it can be 5, it can be 6. And that's what we call a polynomial expression or equation. Now, this is a quadratic expression just because the highest power of the unknown, like in this case is x, is 2. The highest power of unknown cannot exceed 2 and cannot be less than 2. And this is the meaning of a quadratic expression or equation. Now, this is an expression just because the inequality, the equal sign is not there. So this is an expression. This is an expression. Now, we want to look at how we can factorize a quadratic expression. After that, we will now look at it in form of an equation. How can a quadratic equation, how can it be solved? First, we want to look at how a quadratic expression can be factorized. We have x squared plus 4x plus 3. Now, this is the general method of factorizing a quadratic expression. What you just need to do here is that this x squared has a coefficient. The coefficient is 1. You multiply it with the last constant term, which is plus 3. That is, you are going to say plus 3 times the coefficient here, which is 1. Plus 3 times 1 will give us plus 3. That's the first thing you do. You multiply the constant with the coefficient here. The second thing is to put down these values, plus 4. Now you now start thinking of two numbers. Think of two numbers that when you multiply them, when you multiply those two numbers, you are going to have plus 3. And when you add them, you are going to have plus 4. That is, think of two numbers that when you multiply, you have plus 3, and when you add, you have plus 4. The number is 3 and 1. Plus 3 and plus 1. When we multiply plus 3, and we multiply plus 3 times plus 1, it will give us plus 3. And when we add plus 3 plus 1, we are going to have plus 4. So plus 3 and plus 1 is a factor of this expression. That means we can say x squared plus, the plus 3 and plus 1 will replace the 4x. It will be 3x plus 1x. This is 3x and 1x. This will replace 4x plus 3. This 3. The equation is still the same. The expression is still the same thing. X squared, x squared. 4x is now 3x plus x. Then plus 3. Now, we cannot factorize this. Between x squared and 3x, x is common, so we'll bring it out. So we'll be left with x plus 3. X is already out. Plus, between x and 3, nothing is common, so we put 1 outside. We assume 1 is common. Then, we now have x and plus 3. Since we have x plus 3 on both sides, so we pick 1. And we now pick this x and this plus 1. We now have this to be the factorization of x squared plus 4x plus 3. That's the first question. Now let's look at the second question. X squared minus 6x plus 9. The same method. The coefficient of x squared here is 1. You pick the first and the last, you multiply them together. Plus 9 times 1 give us plus 9. Then we have minus 6, you put down minus 6. You now think of two numbers, and when you multiply the two numbers, you are going to have plus 9. And when you add them together, you are going to have minus 6. The numbers are minus 3 and minus 3. When you multiply, minus 3 times minus 3 is going to give us plus 9. And when you add, minus 3 plus minus 3 give us minus 6. So the numbers are minus 3 and minus 3. minus 3 and minus 3. So we now have x squared. So the two numbers minus 3 and minus 3 will now replace minus 6. Minus 3 gives us minus 6, then plus 9. Then we factorize fully. Between x squared and x is common. We are left with x minus 3. Between this and this, 3 is common. We bring it out. We have x. Because this one is negative, we're going to change the sign here to negative. In 9, we have 3. Now, x minus 3 is on both sides. So we pick 1, x minus 3. And we also have x minus 3 also. X minus 3. This is the same thing as saying, this is same thing as saying x minus 3 everything squared. It's the same. And let's look at the third question now. We have 3x squared plus 7x plus 2. The same method. You pick the first number and the last number, you multiply them together. Plus 2 times 3 give us plus 6. And we also have plus 7. So you think of two numbers and when you multiply them together, you are going to have plus 6. And when you add, you are going to have plus 7. Think of two numbers. Now, the two numbers that we can think of can easily be 6 and 1. 6 and 1. When we multiply them, we are going to get plus 6, and when you add them, you are going to get plus 7. So the numbers are plus 6 and plus 1. So we now have 3x squared to replace 7x, 6x plus 1x, which is x, plus 2. Now, these are the two numbers, 6 and 1. 6 and 1. It has now replaced 6x. The equation remains the same thing. Now, between this and this, 3 is common, and x is also common. So here I will be left with just only x plus, here I will be left with just 2. Because x is already outside. Out of 6, we have 3 outside, you are left with 2. Plus, now between x and 2, nothing is common, so we put 1. Left with x plus 2. Now we now have x plus 2 on both sides, so we pick 1. X plus 2. And 3x plus 1. And this is the factorization of this third question. So in our next class, we're looking at more examples on factorization. Thank you.